This is Lesson 10 in Module 10. The topic of this lesson is wireless networks. After completing this lesson, students should be able to discuss the various wireless network types and describe where each is used. Know the different 802.11 standards and which are in use today and in what environments. Be able to describe the different wireless network transmission media and when each might be used, and be able to list and describe some of the problems or issues that face wireless networks. Wireless networks are computer networks that are not connected by cables of any kind. The use of a wireless network enables enterprises to avoid the costly process of running cables throughout buildings or between different locations. The basis of wireless systems are radio waves that connect devices such as laptops and printers to a network and ultimately to the internet. When you connect your laptop to Wi-Fi at a business such as a coffee shop, it is connecting to what we refer to as a hotspot, which connects your computer to that establishment's wireless network. When we talk about wireless networks, we often envision what we have in our homes, as wireless home networks are ubiquitous. Notice in this diagram we have a wireless router which is responsible for communication between the various devices in the home and a link to the internet, commonly via an internet service provider or ISP. Also notice the variety of different devices that are connected to the router, from computers to mobile phones and devices such as printers. A growing addition to this diagram might be the devices that are increasingly becoming common in homes, such as various appliances that fall into the category of the Internet of Things devices. While this is the image we may initially envision when discussing a wireless network, there is much more to the wireless world. Also notice that some of the devices are connected via cables as opposed to using the wireless medium to connect to the wireless router. When we talk about wireless networks, we generally think of four main types of networks. These are local area networks, or LANs, which are computer networks that exist at a single site, such as an office building. They can be used to connect a variety of components such as computers, printers, and data storage devices. LANs may also include other components such as switches, access points, routers, and firewalls. Wi-Fi is a term we most often hear in reference to wireless LANs. Metropolitan area networks, or MANs, connect several wireless LANs. They are computer networks that span a city, small geographical area, a business, or a college campus. One feature that differentiates a MAN from a LAN is a LAN usually consists of a solitary building or area, while a MAN can cover several square miles depending on the needs of the organization who owns the MAN. Wide area networks, or WANs, cover a very large area, like an entire city, state, or country. In fact, some may refer to the internet as a WAN, though others will argue it falls into a different category. A WAN can contain smaller networks, including LANs or MANs. Cellular services are the most commonly known wireless WANs. Personal area networks, or PANs, are our last type. They consist of a network centralized around the devices of a single person in a single location. A PAN could have computers, phones, video game controls and consoles, or other peripheral devices. They are common inside homes and small office buildings. Bluetooth may be used for connecting devices in a wireless PAN. In addition to the four major types of wireless networks we just mentioned, there are several others that you may come in contact with. Let's start with a discussion of ad hoc networks. Ad hoc mode is also referred to as peer-to-peer mode because it does not involve an access point, but is instead made up of multiple client devices. The devices acting as peers within the network connect to each other directly. Here is a diagram of what you might see in an ad hoc network. Notice, as mentioned, that there is no central access point or wireless router to which all are connected. In this case, you can see that there is a computer which may serve as a connection point to the internet, but notice that the many devices, in addition to communicating with this computer, directly communicate with other devices in the network without going through any central device for routing. Continuing with our discussion of other types of wireless networks, let's talk about another that you are likely very familiar with using, and that is a cellular network. A cellular network is a wireless network spread over land through geographic areas known as cells, where each cell includes a fixed location transceiver known as a base station. These cells collectively provide wireless coverage over larger geographic areas. Devices such as mobile phones can continue to communicate even though the device is traveling while transmitting. Cellular networks work well until a user leaves a cell and enters an area in which there is no base station that covers this new geographic area. A typical cell site offers coverage of between 9 and 21 miles. The fixed location transceiver in each cell, known as a base station, is responsible for monitoring the level of the signals when a call is made from a device such as a mobile phone. When the user moves away from the area covered by the base station, the signal level may become weak. When this happens, the base station will make a request to what is known as the Mobile Switching Center, or MSC, to transfer control of the device's communication to another base station that is receiving a stronger signal from the device. This is accomplished without any interaction with the mobile subscriber. This change of base stations is known as a handover. Our next type of network to discuss is a global area network, referred to as a GAN. A global area network refers to a network composed of different interconnected networks that cover an unlimited geographical area. The term is loosely synonymous with Internet, which is considered a global area network by many. The most sought after global area network type is a broadband GAN. The broadband GAN is a global satellite internet network that uses portable terminals for telephony. The terminals connect laptop computers located in remote areas to the broadband internet. Like wide area networks, global area networks are used for supporting mobile across an arbitrary number of wireless LANs, satellite coverage areas, and so forth. The major challenge in mobile communication is the handover or handoff mentioned when discussing cellular communication. A major limitation of a global area network is reception in remote areas unless satellite coverage is being used for the GAN. The final wireless network type we will mention is that of the Dedicated Short-Range Communications, or DSRC, and Vehicle to Everything, or V2X, which are used in intelligent transportation systems. These are used in highly specialized environments such as for communication between autonomous vehicles. V2X then expands this communication to include roadside infrastructure such as traffic signals and electronic message signs. In this diagram, we can see a couple of different types of wireless communication taking place. eNode B stands for Evolved Node B and is the radio base station in 4G LTE networks. eNode B is capable of performing network control functions in addition to establishing mobile network coverage. The V2I links shown stands for Vehicle to Infrastructure, which is simply connecting to the infrastructure consisting of the collection of base stations that are working together. In the diagram, you can also see V2V, or vehicle-to-vehicle communication. This is a fascinating problem facing autonomous vehicle researchers. Think about what is implied in this diagram. You have cars traveling down a highway that are communicating with both local base stations as they move from cell to cell, but are also communicating with vehicles within a specific range to form, in essence, a mobile small network. If a vehicle traveling in front of you detects a hazardous condition, such as an accident, it can communicate directly with vehicles in range of it to warn of the situation, even if the vehicle is out of range of a cellular base station. Let's talk about the protocols that are used in wireless communication. We will start by paying homage to the one that really kicked things off, Aloha Net. Development of the Aloha Net was begun in 1968. The reason for its creation was the desire to connect users in Oahu and the other Hawaiian Islands. At this time, there were no PCs. Computing was accomplished using large mainframe computers, which were expensive. The goal was to use low-cost commercial radio equipment to connect users on the other islands to a central time-sharing computer on the main Oahu campus. The first version utilized two separate frequencies in a hub configuration, with one frequency being used for outbound traffic and the other for inbound traffic. When the central hub correctly received a communication, it sent a short message to acknowledge it was received. If the sender did not get an acknowledgement as a result of something such as a collision between two sites transmitting at the same time, then the sender would wait a random period of time and then try again. This method is referred to as pure aloha. It was the basis for the development of Ethernet. The key aspect of Aloha Net was the use of a shared medium, which simplified communication compared to what was being done on the ARPANET. Here is a simple diagram illustrating the goal of the Aloha Net. Notice the comment concerning the Aloha Net's method of communicating over shared media and thus having to handle things such as collisions. This was used in the development of Ethernet, which is also based on communication over shared media. Aloha Net was the protocol that kicked things off, but eventually other protocols were developed. Today, the networking standard used by wireless architecture is IEEE 802.11. However, this standard is in continual development and new amendments or versions come out regularly. Amendments to the standard are assigned letters, and while many amendments have been released, the most common are 802.11a. This original amendment added support for the 5 GHz band, allowing transmission up to 54 megabits of data per second. The 802.11a standard makes use of frequency division multiplexing. It splits the radio signal into subsignals before they get to a receiver. 802.11a is an older standard and has been largely replaced by newer technology. 802.11b added faster rates in the 2.4 GHz band to the original standard. It can pass up to 11 megabits of data per second. It uses complementary code keying modulation to achieve better speeds. 802.11b is also an older standard and also has been largely replaced by newer technology. 802.11g standardized the use of frequency division multiplexing technology used in 802.11a in the 2.4 GHz range. It was backwards compatible with both 802.11 and 802.11b. 802.11g is an older standard and has been largely replaced by newer technology. 802.11n was once the most popular standard. 802.11n was the first time a specification covered both the 2.4 GHz and 5 GHz bands. This protocol offers better speed when compared to those that come before it by leveraging the idea of transmitting using multiple antennas simultaneously, usually called multiple in, multiple out, or MIMO technology. 802.11n is an older standard, but some older devices may still be found in use. An addition to the standards for wireless access in vehicular environments is 802.11p. It is designed to support intelligent transportation systems as we advance with our autonomous vehicle technology. 802.11ac was only specified for the 5 GHz band. It built upon the mechanisms introduced in 802.11n. While not as revolutionary as 802.11n was, it still extended speeds and capabilities in the 5 GHz band. Most devices currently out in the wild are likely 802.11ac devices. 802.11ac technology was released in two main groups, usually called waves. The primary difference is that Wave 2 devices have a few more technical capabilities when compared to Wave 1, but it is all interoperable. 802.11ax, much like 802.11n, unified the specification across all bands. In the name of simplicity, the industry has started to refer to it as Wi-Fi 6. Wi-Fi 6 has expanded the technologies used for modulation, which allows a certain amount of parallelism to the transmission of packets, with the system making more efficient use of the available spectrum and improving the overall network throughput. Wi-Fi 6 is the latest technology and is what most new devices are shipping with. Transmission media refers to the method used to transmit data from a sender to a receiver. There are two types, of which we are only discussing one of them in this slide. The two are wired or guided and wireless or unguided. When discussing Aloha Net, broadcast radio is introduced. Broadcast radio is likely the first kind of wireless communication. Radio transmitters send out data in the form of radio waves to receiving antenna. Radio waves are forms of electromagnetic signals. Signals are relatively narrow, and waves can be sent across various frequencies. This is why your car radio is able to receive signals from many different radio stations. Microwave transmission media refers to the use of microwave frequencies or microwave technology to transmit data in the form of electromagnetic waves. This type of technology transmits data over long distances. Microwave transmission can occur between surface locations and satellites, as well as 2 points on the ground. This is a line of sight method of communication. Infrared transmission media refers to the transmission of data or information through light waves, better known as infrared radiation. It is a type of mobile technology used to transmit data over short distances. Infrared transmission is used to transmit data to devices within a line of sight. Infrared or IR radiation represents a type of electromagnetic radiation with wavelengths longer than visible light but shorter than radio waves. Infrared is common in homes in devices such as TV remotes. Satellite transmission media involves the use of communication satellites in space to transmit data, voice, and video signals over long distances. These satellites orbit the Earth and facilitate various communication services, including television, broadcasting, internet access, telephone calls, and global positioning systems known as GPS. Satellite transmission provides widespread coverage and connectivity across vast geographical regions, particularly in remote areas where terrestrial infrastructure is impractical or unavailable. Optical wireless systems operate using wavelengths ranging from 1330 nanometers to 1550 nanometers. These are most common wavelengths used in optical fiber systems. In comparison, the human eye can detect wavelengths in the 400 to 700 nanometer spectrum. Optical wireless requires line-of-sight communication between transmitter and receiver. Bluetooth is a relatively new technology when compared to the others, but is becoming increasingly prevalent. It is a simple method to send information across a short distance. Bluetooth was originally designed to be a replacement for physical cables. However, it does have its downsides. It has a maximum reach of 30 feet. This can be reduced further, but not entirely blocked by walls and other solid items. There are several common components that you will hear discussed when researching wireless networks. These include wireless routers, which act as the base station, and endpoints, which can be computers, mobile devices, printers, and other such devices. In most cases, the wireless router is also the internet connection. Wireless access points, or WAPs, are the base station that serves as a hub to which other stations connect. The access is that of the stations to the network, but it may also mean internet access. This sounds a lot like our definition of a wireless router, so it might help us to describe the difference between a wireless router and an access point. A router is an intelligent device that routes data to and from the devices connected to it and can also serve other functions such as a firewall. A wireless access point provides wireless access to an existing network and nothing more. Wireless Network Interface Cards, or NICs, are a hardware component installed in a computer to enable network connectivity. It serves as a physical interface between the computer and the network, allowing transmission and reception over a wireless connection. Wireless bridges are used to connect a wireless LAN to a LAN or to an access point. Wireless repeaters, also known as wireless range extenders, are used to take an existing signal from a wireless router or WAP and rebroadcast it. This allows devices that are too distant from the router or WAP to be connected by boosting the signal. Wireless controllers are known as network adapters, which are an integrated circuit or chip embedded on a computer's motherboard. It performs similar functions to a network interface card, but is directly integrated into the computer's hardware. Like NICs, they enable data transfer between the computer and the network. For several years, we have heard cell phone providers singing the praises of 5G technology and how it is going to revolutionize communication. But what is 5G? 5G is the 5th generation technology standard. So then, out of curiosity, what were the other generations? 1G was the first generation of wireless technology. It supported voice-only calls. It utilized analog technology. The maximum speed of 1G was 2.4 kilobits per second. 2G, the second generation, occurred in 1991 and took cell phones from analog to digital. It also introduced call and text encryption as well as data services consisting of the short message service, commonly referred to as SMS, and multimedia messaging service, known as MMS, which allowed messages with images and videos. 2G speeds are generally around 50 kilobits per second. The 2.5 and 2.75G interim standards introduced data transmission. 3G was introduced in 1998 and provided faster speeds, which made mobile internet access possible. The max speed of 3G was 2 megabits per second. 4G, introduced in 2008, increased speeds again, allowing for applications such as mobile gaming services, high-definition TV, and video conferencing. Max speeds of 4G when the device is moving is 100 megabits per second. Stationary up to 1 gigabits per second. 5G is the latest generation. It introduces much greater speeds, up to 2 gigabits per second. It also promises lower latency rates and greater energy savings. In addition to its use in mobile networks, 5G is also being introduced to the private network environment, especially in industrial and enterprise networks, wanting greater speeds. Is there anything after 5G? There is a 6G planned to follow 5G. It is expected to be available around 2030. In labs, speeds have been obtained for this next generation in the 200 gigabits per second range. With all of the great things about wireless technology, there are some problems and issues with wireless. First on the list is the security of the transmissions. Unlike a cable which connects two locations, a wireless transmission is broadcast over an area where anybody within that area can pick up the transmissions. Thus, the reason that encryption is important to wireless transmissions. Fading occurs when a radio signal becomes too weak in a certain area or over certain distances to be received adequately. The attenuation of a signal purely as a result of the distance is also known as free space loss. Interference is a disruption in Wi-Fi signals caused by other electronic devices or networks. Common causes of Wi-Fi interference include devices like microwaves and cordless phones, as well as other Wi-Fi networks. Absorption and reflection are related as they both involve a signal impacting an object of some sort, which can cause different problems. Absorption is another issue that can cause fading problems. Absorption is simply the situation where a radio signal is absorbed by various objects. Signals can be absorbed by buildings, trees, or hills, among other things. Reflection occurs when a signal bounces or reflects off of some surface. This can cause interference as it will mean the receiver may receive the same signal multiple times. This is a type of multipath fading. Multipath fading is the propagation phenomenon that results in radio signals reaching the receiving antenna by two or more paths. Causes of multipath include atmospheric ducting, ionospheric reflection and refraction, and reflection from water bodies and terrestrial objects such as mountains and buildings. When the same signal is received over more than one path, it can create interference and phase shifting of the signal. Hidden nodes are nodes that are out of range of other nodes. This means that two nodes at opposite extremes of an access point range will not be able to transmit to each other. They will also not be able to detect collisions, as they will not be able to detect that the other is attempting to transmit to the access point. In this situation, carrier sense multiple access with collision detection, or CSMA/CD, will not work. While the hidden node problem is an issue because of collisions, the exposed terminal node problem results in a waste of concurrent transmission opportunities. This occurs when two terminal nodes can see each other even though they transmit to different access points. If one starts to transmit, the other will not transmit because it thinks there will be a collision when one will actually not occur, thus wasting the opportunity to transmit. In the hidden terminal node example, A can communicate with B and C can communicate with B, but A cannot reach C nor C A because they are out of reach. This means that if they both want to transmit to B, they won't be able to detect that the other is transmitting and collisions can occur. In the exposed terminal node example, B and C are within transmission distance of each other, but B wants to send to A and C wants to send to D. If B is transmitting to A, C will not attempt to send to D because it believes there will be a collision. Thus, an opportunity for C to transmit will be wasted. For this lesson, there are 4 required videos. There are also two optional videos. One goes into more detail on Wi-Fi 6. The other is an interesting one addressing whether 5G is actually harming us. This is actually a concern of a number of people today. Time for a quick check of your knowledge on the topics covered in this lesson. In which technology generation was mobile internet access first made possible? First generation, second generation, third generation, fourth generation, or fifth generation? Mobile internet access was first made possible in the third generation. Which type of wireless networks are used with intelligent transportation systems? Choose all that apply. PAN, GAN, DSRC, or V2X? The answer is both DSRC and V2X. Which addition or amendment to the 802.11 standards is intended for wireless access in vehicular environments? 802.11b, 802.11g, 802.11p, or 802.11ax? The standard intended for wireless access in vehicular environments is 802.11p. Which wireless terminal problem or issue can result in a waste of concurrent transmission opportunities? Exposed terminal nodes, absorption, interference, or hidden terminal nodes? Exposed terminal nodes can result in a waste of concurrent transmission opportunities. This concludes Lesson 10 in Module 10. This also concludes Module 10.